Hello, my name is Om Sahagya. I'm Joel Tyson, and today we are here to discuss conventional saw cutting versus abrasive jet cutting. So, our company would like to move to an advanced manufacturing process to replace conventional saw cuts, which is abrasive jet cutting. And an abrasive water jet cutter is right here in this photo to the left. Here's just an example. It's EWJ4020. You can just see it's very large. It's a very large scale item and very expensive as well. So for conventional saw cutting, we have table saws, band saws, and handheld saws, and there's multiple other types of other saws. So on the top left, you can see a handheld saw, just manually using just back and forth motion to cut through your material. Table saw on the top right, which uses a circular blade with an angular velocity, which cuts through your material. And then on the bottom right, there's a bandsaw, which a blade is looped around two wheels, two or more wheels, and one of those wheels spins on the motor, and that just causes the blade to move. And in a downwards motion, that's where you make the cut. And then on the bottom left, there's just an automated saw. So you use teeth and mechanical motion for cutting materials, and different saw types are used for different thicknesses and materials.
So abrasive jet cutting is industrial use and it uses high pressure water forced through a nozzle to create precise cuts through tough materials. It's an automated process using CNC. It's a very expensive initial investment. The way it works is it infuses water with tiny abrasive pieces which cut away at the workpiece. So you can see a picture of how this works. The leftmost picture where the water is mixed with the abrasive right before being pushed out through the nozzle. It's essentially water erosion, but greatly sped up. So it can give like a smooth surface finish. And the abrasives include garnet, olivine, aluminum oxide, and silicon carbide, but the most common is garnet. So the comparison is conventional saw cuts use mechanical teeth. It's mechanical cutting using teeth, and abrasive jet cutting is done using the water jet, as we just saw with the abrasive. So with saw cuts, when it uses the teeth, it causes a lot of friction and heating. But abrasive jet cutting causes very little heating, and especially not enough heating to cause any deformation or microstructural changes. Conventional saw cuts you can use on metals, woods, and plastic, but the blades will struggle with hard and brittle materials. Abrasive jet cutting can virtually be done with any material since it's shooting out water and abrasive. It doesn't cause any wear to any parts like the saw. Conventional saw cutting is used mainly for creating straight cuts, but abrasive jet cutting can be used to cut out much more complex geometry. For conventional saw cuts, the tolerance is between a quarter and a half of a millimeter, but a typical water jet tolerance is within 0.1 millimeters, so there's a lot more tolerance with an abrasive jet cutting. You can get more accurate cuts. And then conventional saw cutting is cheaper, while abrasive jet cutting is more expensive. So it's better to use conventional saw cutting when making long, straight, high volume cuts. So if the product being manufactured needs to be manufactured fast and cheap, especially with very little barrier to entry, then a conventional saw will be better. And it's also better for small scale manufacturing without strict tolerances. Because the fixed cost to start saw cutting is much lower than the fixed cost to start jet cutting. So saw cutting can be a much more economical option, especially if doing smaller scale manufacturing. When is it better to use abrasive jet cutting? It's better when making complex non-straight cuts, because it allows you to cut more complex geometries with curves, while conventional saw cutting is limited to straight cuts. So if you see to the left here in this image, an abrasive water jet is used to cut out what looks like a fan for maybe like an engine. And as you can see, that geometry would have never been able to be cut out with any type of conventional saw cutting. Another reason when it's better to use abrasive jet cutting is when cutting sensitive materials, because the cutting is being done with water and there's no heat created like we talked about, so it doesn't cause any warping or microstructural changes. And another reason is because there is when there's strict tolerances that need to be upheld. So there's, as we saw, the tolerance for an abrasive water jet is within 0.1 millimeters, which is a lot smaller than conventional saw cutting. So when you're trying to make accurate cuts, it's a lot better to use abrasive jet cutting.
So some capabilities and cost limitations of the advanced manufacturing process of abrasive jet cutting. So water jets use about 2 pounds of garnet per minute. Cost of garnet is approximately 25 cents per pound. Therefore, the abrasive would cost about $30 an hour to run. And this could be higher depending on the water jet and how much abrasive is fed into it. So it could be higher even. And it's about $150 per hour to run the water jet. A lot of training is needed, so operators must understand the principles of CNC, and maintenance staff need to be able to fix issues that arise because there's a lot more moving pieces with the abrasive water jet. So more moving parts equals more things that can break. And also maintenance staff needs to understand the electronic components a little bit better, because compared to a normal table saw or bandsaw, there's a lot more electronic components, which are very complicated to repair. So doing a manufacturing readiness analysis, the workforce conventional saw training is very common across all industries, across globally. Most operators will know how to use a bandsaw, table saw, and all other types of saws safely. So, but abrasive jets require specialized operator training. Therefore, this is going to be a big upfront cost training all the operators up to speed on how to use a abrasive jet cutter. And process capability, conventional saws can be constantly and they have a quick turnaround. So you could just keep cutting all day, but abrasive jets are much slower because they require programming and they're more precise. So cost benefit, conventional saws are cheaper and easy to maintain, and abrasive jet water jets are more expensive and much harder to maintain, as previously mentioned. So in industrial base, conventional saws are mostly standardized, like standardized blades, blade sizes, and all the different parts and pieces on a saw just mostly standardized. Abrasive jets have more specialized parts. So each jet has like a different nozzle, pump, and abrasive depending on what you are cutting and just the manufacturing process it's used in. So these specialized parts are going to be harder to replace. So material management, both are subtractive manufacturing, therefore there will be material waste, but however, with the automation of the abrasive water jet, we can minimize waste by efficient programming. To conclude, conventional saws are at the highest manufacturing readiness with an MRL score of 10, while abrasive water jets are at a 9. They can be used in lower yield production, but they are very specialized and process dependent. What should our company go with? We should go with conventional if our primary manufacturing mostly wooden pieces that don't have strict tolerances and are simple shapes, boards or blanks, non-critical use pipe sections, furniture. We should move with abrasive jet cutting if our primary manufacturing route is more metal or brittle, parts with higher tolerances such as granite or marble countertops, adapter plates, and stainless steel instrument panels. So here are our references. So we avoided websites of companies trying to sell stuff or just that have like an agenda to push with one way or the other. So we use scientific websites, journal articles, and third-party comparisons of both. Thank you.
Thank you.